This is MAT175, Lesson 7, Section 2.6. We're into Unit 2 now, Mathematical Models, Building Functions. We're going to look at building and analyzing functions. Here we have a parabola, and that equation is y equals to x squared minus 1. And we want to find the distance between some point to the curve of the parabola. And we're going to call that distance d. And we want to express the distance d from point P to the origin. So this would be point P here to the origin. Well, in order to do that, we have to take a look at, here we have a reconstruction of that same parabola, and we have our origin and point P. Here's our distance, and we're going to use the distance equation. Square root of x2 minus x1 parentheses squared plus y2 minus 1 parentheses squared. And first thing we're going to do is we're going to look at the distance equation where we from the point 0, 0, and then we're going to use that as part of our equation, and we're going to use that to construct our overall our function in the long run. Okay, so we're going to use x goes in for x2 minus 0, and then we're going to close that parentheses squared plus, and then we're going to put y in for y2 minus y1 is 0, close that squared, and we're going to apply the square root all the way across that. Well, anything minus 0 is that same number, so this would be x minus 0. That's just going to be x, and since it's squared, it'll be x squared. And so this is y minus 0, that's just y, and that'll be squared, so that's x squared plus y squared. And we cannot simplify this. In other words, we cannot say that this is x plus y. Okay, that would be incorrect because of the plus. If we had the square root of x squared y squared like this, yeah, then we could say that this was xy. But because of the plus, we can't simplify that. Okay, so that's the first part of our problem. Now, we want to express the distance d from point P in the origin as a function. Well, we have this equation here. We're using x squared minus 1 is our equation. So this equation here is y equals to x squared minus 1. So what we're going to do here is it's like we're cutting this y out, and then we're going to put parentheses there. And so this would be x squared plus, and then we put parentheses where the y was. And now we're going to put the x squared, since y equals to x squared minus 1, we're going to substitute that equation in for y. So this would be x squared minus 1, and then we're going to, of course, apply the square root over that, and then we're going to go ahead and FOIL that. So that's going to be square root x squared plus, of course, that'll be like saying x squared minus 1 times x squared minus 1, and we FOIL that, and we're going to get the square root of x squared plus, now x squared times x squared, that'll be x to the fourth, and then x squared times negative 1 is a negative x squared times negative 1 is a negative x squared and negative x squared is a negative 2x squared. And then negative 1 times negative 1 is a plus 1. So from there, we can simplify pop 1x squared and minus 2x squared. That's going to be simplify out to x to the fourth minus 1x squared plus 1. And that's our distance function. And so that'll be known as d of x. Alright, and then that's what this is here. Okay, now the next thing we want to do is what is d if x equals 0? So we're going to basically, what we're looking for here is d of 0. So basically we're just plugging 0 in here for x. And so that'll be 0 to the fourth, basically, minus 0 squared plus 1. And that's just going to be the square root of 1. Well, 1 times 1 is 1, right? So the square root of 1 is just 1. And so that'll give us a point of 0, 1. So if we're looking at here, when x is 0, we're looking at that point right there. That distance is 1. Alright, so if we're looking at, now let's say we want to know what is the distance if x equals 1. So now, use different. So now let's say we want to know d of 1. So that'll be the square root of 1 to the fourth minus 1 squared plus 1. And so 1 to the fourth, that's just 1. And 1 squared, that's 1. And then plus 1. So again, we get the square root of 1. And again, that's 1. So that would be 1, 1. And so that's what this is here, d of 1. So at 1, we get a distance. We also get a distance of 1. Now at 2 and 3 and 4, it's going to be different. Okay, what is d if we have the square root of 2 over 2? So we plug in square root of 2 over 2 here, so that'd be square root of 2 over 2 to the fourth minus square root of 2 over 2 squared plus 1, and we get the square root of 3 over 2. Well, let's see why that works out the way that does. So here we want to know what is d at square root of 2 over 2. So we'll put in here square root of 2 over 2 to the fourth minus, and this will be square root of 2 over 2 close parentheses squared plus 1. Well, this is like saying square root of 2 over 2 4 times. That's like saying square root of 2 times the square root of 2 times the square root of 2 times the square root of 2. Well, square root of 2 times the square root of 2 is 2. And square root of 2 times the square root of 2, that's 2. So 2 times 2, that'll be 4. So that'll be 4 minus, and then this is square root of 2 squared, that's 2. So this will be 4, we don't want to forget the denominator, this will be 2 times 2 is 4 times 2 is 8 times 2 is 16. So that's 4 over 16. And try to fix that. And so this will be 2 over 2 squared, that's 4, plus 1. Well, we know that we need a common denominator here, so we need to go ahead and multiply 4 over 4 here, and this will be 16 over 16, so that we can get our common denominator. And so that'll give us the square root of 4 over 16 plus, minus 2 times 4, that's 8 over 16, plus 16 over 16, and so we get 16 minus 8, that's 8. 8 plus 4, that's 12. So we get the square root of 12 over 16, and so we can go ahead and simplify that, and we know that 4 can go into both. 4 can go into 12 3 times, 4 can go into 16 4 times, so that'll be the square root of 4 is 2, and then this will just be the square root of 3. So we get square root of 3 over 2. And that's what we have here. Okay, now we want to point from, let P be a point xy on the graph of our x squared minus 1. Use the graphing utility to graph the function, and then round to 2 decimal places. Find the values at which the local minimum. So basically we need to take this equation here, put it into our y equals in our calculator, and then from there we're going to go to, on our calculator, we're going to go to second in calc, and then we're going to go to 4, or no, 3 for our local minimum, and then find our local minimum for that point. And that's all there is for that problem.